Microsoft OTTER showcases a stunning breakthrough in AI reasoning and logic. OTTER represents a state-of-the-art vision language model, or VLM, developed on the Open Flamingo platform with the primary objective of revolutionizing our interaction with visual content. It not just sees images, but it understands them. It can give you in-depth responses the likes of which have never been seen with other VLMs before. So stick around till the end if you want to know how this amazing AI works. Introduced by Microsoft, OTTER is a multimodal language model specifically designed to excel in visual understanding. OTTER was trained extensively on the comprehensive Mimic-It dataset. This dataset helped OTTER become really good at understanding and learning from pictures and videos. Rigorous evaluations conducted on vision language benchmarks have uncovered its exceptional aptitude in multimodal perception, reasoning, and contextual learning. It can figure out what's happening in a picture or video and make sense of it based on what it sees. Notably, OTTER consistently demonstrates a remarkable ability to align precisely with the intentions of its users. It could understand and follow instructions given in simple or natural language easily. Human evaluations confirmed OTTER's ability to accurately interpret and execute complex tasks based on natural language instructions. So it's able to grasp human intentions quite effectively, making it a valuable tool for tasks requiring instruction interpretation. It has been improved to accommodate video inputs in OTTER version 0.2, enabling it to analyze frames and multiple images as contextual examples. If it's given a video, it can look at the different images or frames inside the video and understand what's happening in each frame itself, as well as give it context, making OTTER more capable and versatile in the process. OTTER can learn new concepts and become smarter by being exposed to a particular set of instances. This is done by fine-tuning the Mimic-It dataset. By watching pictures and movies, it can better understand various circumstances and obey directions. To put it simply, OTTER can comprehend and carry out tasks using images and videos, even if it wasn't trained on them specifically. It's able to generalize to perform its task. It keeps improving at understanding and can pick up new information by studying examples. This makes it quite useful for comprehending and carrying out duties according to what people want it to perform. Sounds great in theory, but let's take a look in practice. In the research paper, they've provided us with two types of demonstrations for OTTER: OTTER's ability to follow instructions and its ability to learn. Let's see how good it is at following instructions. OTTER was trained on pairings of instructions and visuals, which helped it become even more powerful at comprehending and adhering to directions. In this example, OTTER was given an image and asked to describe it in detail or tell the user about its details. You can see that OTTER can describe images in greater depth and adhere to directions more precisely than Open Flamingo. This extremely detailed description of the images seems very impressive, almost as if the description is from a book where the writer is describing the scene to its fullest extent in order to paint a picture for a reader. The reason why OTTER is so good at this is because they jointly designed the model and used particular data to increase OTTER's performance. They paired the Mimic-It dataset's wide range of instructions with a powerful language decoder that can comprehend and produce human language. OTTER improved its comprehension of human language and its ability to apply that understanding to images by being trained with these instruction-image combinations. But such a comprehensive representation of the image surely can't be 100% accurate. The writers of the research paper have acknowledged a downside of OTTER. OTTER is prone to language hallucination. Hallucination refers to when an AI lies to you and makes up information. This is because OTTER is built on Open Flamingo, which was also built on LLaMA, meaning the hallucinations are an unfortunate inheritance from LLaMA. They say that these hallucinations aren't related to the image and may be fixed if some negative examples are introduced in the training data. But that's enough about the negatives. Let's talk about something positive, like leaving a like if you're enjoying the video and subscribing for more videos like this. Now let's move on to a few more examples. Tests were conducted to determine OTTER's capacity for abstract thought and situational understanding. They wanted to see if it could handle situations that called for more in-depth comprehension and sophisticated reasoning. In this example, OTTER was asked what could happen if drivers got confused by the traffic signals in the intersection. OTTER was able to identify significant information in the photo, but OpenFlamingo failed to do so, giving only a brief answer that really didn't account for multiple situations. OTTER answered the question rationally and demonstrated that it had a greater understanding of the circumstances. In this case, OTTER was able to determine what was going on with the traffic light while also taking into account other crucial factors, including collisions, backups, and disturbances in the flow of traffic. It applied common sense in this situation, which is remarkable. OTTER's aptitude represents a significant advancement in computer vision and the comprehension of natural language because regular image captioning models are unable to perform this kind of clever thinking. Now let's take a look at examples that showcase its in-context learning capabilities. In this example, they show OTTER's capacity to respond to questions concerning visuals in one instance. To help OTTER comprehend and respond to particular subtasks, like elaborating on memes or debating the dangers of sports, users supply both questions and examples in the form of images. So you're basically teaching OTTER what something is through an example, and then seeing it perform using information gleaned from said example. User inputs are short, brief, and constrained. Despite this, OTTER is able to provide more detailed answers in these situations. It accomplishes this by utilizing data from the images and other samples offered so that it can understand the content and context of the questions, giving you more informative answers that don't rely on surface-level meaning. OTTER is designed to learn from both words and images together, similar to Flamingo and OpenFlamingo. This process requires the language model to be conditioned to associate certain images with certain captions or a pair of question answers. If you want to try it out for yourself, Microsoft has a live online demo open to anyone. There's one for OTTER Video and OTTER Image. Just know that the model is hosted on a system with only 2 RTX 3090 graphics cards. While that sounds beefy, it's not really that much processing power, so it may slow down the model or the sites might be down completely because of heavy traffic. Now there's a lot of emphasis placed on the Mimic-It dataset. It's what allows OTTER to perform with the level of quality it does currently. Large language models need clear and high-quality instructions in order to perform well. This is crucial for jobs that combine words and images, such as describing intricate scenes, and it's doubly important for zero-shot performance as well. We need a variety and a large number of instructions for VLMs in order for them to learn effectively. But the availability of such a data set that has vision language tasks in high levels of quantity, variety, and creativity is low. As such, the researchers observed that it's hard to achieve generalization of interactive VLMs because of this limitation. Generalization is very important as it's related to zero-shot performance. An AI achieving generalization will be able to transfer its knowledge from training to new situations it's never seen before. That's why the researchers behind OTTER found it very important to create the Mimic-It dataset, which cost over $20,000 to make. It stands for Multimodal In-Context Instruction Tuning. The Mimic-It dataset represents a staggering 2.8 million instructions, and 2.2 million of those came from images and videos, meaning they're multimodal in nature, not just limited to words or images. This dataset is full of instruction response pairs, similar to the learning example shown before. Stuff like natural dialogue, image and video descriptions, image comparisons, scene understanding, and question answering are just a few examples of what's in this dataset. The goal of each pair is to provide contextual information which allows VLMs to improve their perception, planning, and reasoning, tackling real-life situations that rely heavily on context, like knowing where you left your car keys or telling you the best way to land your glider, meaning it's good for the creation of visual assistants that could help in these real-life scenarios through the power of AR. And it isn't limited to just English either. They cover over 8 different languages, which is an added bonus for any kind of AI assistant. So what do you guys think of OTTER AI and the Mimic-It dataset? Could we be seeing much better VLMs now and maybe even the rise of visual assistants? Be sure to leave a like and subscribe for more AI news in the future.